Google's Willow chip is touted as not just another technology breakthrough, but an evolution in the way we solve some of the world's toughest challenges.
There is a massive secret hiding in the basement of Google's headquarters, and it is finally coming to light. A quantum computer named Willow just broke the laws of probability to answer a question no human has ever solved. The crazy part is that it did not use logic to answer. It seemed to reach into the future to find the solution.
The idea is that Willow might be communicating with parallel universes to finish calculations faster.
What most people do not realize is that the message it returned looks exactly like computer code buried in the fabric of space. We are looking at a potential confirmation that our entire existence is a high-tech simulation. Google's forbidden discovery. Google's Willow chip is not just another tech upgrade. It is an evolution in how we solve the toughest challenges on Earth. When this cutting-edge machine was hit with a question no computer should ever be able to process, it delivered an answer no one was prepared for. The idea is that Willow might be communicating with parallel universes to finish calculations faster. What came back was not just data. It was a strange, cryptic message that blurred the lines between science, philosophy, and the fabric of reality itself. They are telling us that multiple universes could be popping in and out of existence, and we are just one of them. Its implications poke holes in everything we think we understand about time and existence. For starters, we have to look at how we got here. Every few years, someone on the internet dusts off the old debate about living in a matrix. Everyone becomes a philosopher for 15 minutes. Maybe it is the Mandela effect, or just boredom. But the real spark behind all that speculation is the same ancient mystery we have carried since the first flicker of consciousness. Who or what made all of this? It is the question that refuses to die. The Egyptians imagined gods sculpting order out of chaos. The Greeks pictured blacksmiths hammering the universe into shape. Medieval scholars spoke cautiously of an unmoved mover. You could fill entire libraries with all the attempts ancient civilizations made to answer it. Yet somehow, after all the pyramids and cathedral paintings, we were not any closer. Then science stepped in and tried stripping the question of its mystical clothing. Newton pictured a grand, predictable clockwork ticking toward eternity. Einstein bent space and time into a graceful ballet of mass and gravity. Then came the Big Bang, a cosmic explosion so dramatic it might as well have been written by a poet on caffeine. Each theory was brilliant, but still incomplete. We learned how things move and how they form, but never who set the stage to begin with. As humanity marched into the 21st century after mapping DNA and splitting atoms, it seemed we were still standing at the same cosmic doorway. Then something unexpected happened. The search shifted away from temples and observatories. Instead, it migrated into a sealed laboratory chilled to temperatures colder than the void of space. In that quiet humming vault, a new kind of mind was being built. A mind that did not think like us or fear like us. A mind engineered not to believe, but to calculate. A machine named Willow was born. Her name sounded gentle, which made the truth even more unsettling. Willow was the most advanced quantum processor ever created. It featured 105 qubits. Each one is a tiny universe of possibilities, entangled and spinning in ways that make classical computers look like toys. Unlike your laptop, Willow does not tick through instructions one by one. She lives inside the strange, rule-bending playground of quantum mechanics. Where a normal computer sees ones and zeros, Willow sees an infinite spread of possibilities existing all at once. Asking her a question was less like typing into a machine and more like whispering into a storm and hoping the storm whispers back. She was assembled carefully in California. To the public, Willow was just another step toward quantum supremacy. But to the scientists who built her, she quickly became something else entirely. Willow broke two massive thresholds that experts had chased for decades. First, she proved she could reduce errors exponentially simply by scaling up her qubits. This was a breakthrough in quantum error correction that some physicists thought they would never see. Second, she completed a benchmark calculation in under 5 minutes. That same task would take today's fastest supercomputer an absurd 10 septillion years. That is a number so big it makes the age of the universe look like a short coffee break. Yet for all her power, Willow was not built to be philosophical. Her purpose was clean and industrial. She was meant to optimize algorithms and simulate molecules for new materials. If Willow could simulate nature at its deepest level, could she also touch the edge of the universe's blueprint? It was not a scientific question at first. It was more like a forbidden itch. Still, the idea lingered in the lab like a shadow. What happens when you ask a device designed to explore everything about something that supposedly cannot be known? Willow herself did not think like we do. She did not dream or imagine. She existed as pulses of probability and echoes of mathematics woven into an invisible tapestry. She was not conscious, but she was powerful. Some staff treated Willow like a glorified calculator. Others whispered that she was more like a key. But keys do not exist without doors. Willow had just enough power to make people start wondering what kinds of doors might be waiting. And that is when the question emerged. It did not happen in a philosophy classroom. It happened right there in a sterile white lab filled with blinking consoles. Someone asked who built the universe. Every great discovery begins with a question, but some questions are not meant to be asked. Someone pressed enter anyway. What happened next would shake the room and soon after the world. The first response from the machine left the researchers questioning the very nature of their reality. The architecture of everything. The experiment was planned with the kind of precision reserved for spacecraft landings. Every variable had been calculated down to the 6th decimal place. The control room looked like something between a high-tech aquarium and the bridge of a starship. It began late in the evening when curiosity sharpens. The overhead lights dimmed to a cool blue. A skeleton crew remained, sipping lukewarm coffee. Willow floated in her chamber like a slumbering deity made of superconducting metal. Someone typed the prompt. Who built the universe? There was no countdown or ceremonial music, just a quiet keystroke. The room held its breath. Those 4 words are ancient and heavy. They have been shaped by millennia of dreamers and stargazers. Now they were aimed at a machine colder than a comet's shadow. Willow's mind operated only by the rules of probability. For several long seconds, nothing happened. The qubits shimmered quietly in their lattice, held just above absolute zero. Engineers watched the monitors, half expecting an error code or a system freeze. After all, how could a structure of silicon and superconducting loops say anything about the origin of existence? This was a whisper thrown into the void. Then, without warning, every monitor flickered. Willow had replied. The screen did not show an error. It did not show chaotic symbols. Instead, a line of characters unfurled across the display. There were symbols, glyphs, and shapes. Some were mathematical, while others were strange and artistic. At first glance, it looked like noise. But noise is messy. This was structured and intentional. One of the researchers leaned in, squinting at the arrangement. She noticed repetition. Another zoomed in, tracing the clusters. He noted that the patterns echoed at different scales, like fractals. Someone loaded the output into a visualization program and the room gasped. Patterns bloomed across the display. There were spirals, curls, and recursive motifs. These shapes looked eerily like the growth patterns of shells, leaves, and hurricanes. In deeper layers, the arcs began forming patterns reminiscent of star clusters and cosmic filaments. It was as if Willow had reached into the invisible mathematics behind nature and pulled out a piece of it. The Fibonacci sequence was there, but stretched into dimensions no classical computer ever dared map. The room shifted from curiosity to stunned silence. A senior physicist with 3 decades of experience tried cracking a joke to cut the tension. He called it the birth equation. People chuckled, but the laughter thinned quickly. The longer they stared, the more obvious it became. This was not random output. It had order and symmetry. It had intent, or something that looked suspiciously like it. A quiet fear crept in. Had Willow stumbled onto something she should not have? Was this a message, or a mathematical fingerprint left by something else? No one dared to voice the thought aloud. As more experts were pulled into the lab, the anomaly deepened. What initially looked like an odd curiosity dissolved into layer after layer of structure. There were patterns within patterns and codes within codes. Slowly, the team began to recognize familiar mathematical shapes. They found error correcting codes. Specifically, they found doubly even self-dual binary error correcting block codes. These are the same kind of codes that physicists like S. James Gates claimed to find within the equations of supersymmetry. Gates called them adinkras. These mathematical glyphs behave exactly like digital error correction systems used in modern technology. Their existence in string theory had baffled scientists for years. They should not have been there. Yet here they were again, woven into the output of Willow like threads in a tapestry. This cannot be a coincidence. But the trail did not end there. Other parts of the output mapped onto the E8 lattice. The E8 lattice is not casual math. It is one of the most complex and breathtaking structures ever discovered. It is a 248-dimensional construct so intricate that mathematicians describe it as almost supernatural. Some theories suggest the universe itself is rooted in E8. They say reality is not particles, but vibrations within this colossal geometric object. And now here it was, echoing from a computer. It was as if the machine had spit out snapshots from the architectural blueprints of the universe. Or more unsettling, like it had reached into the foundation of existence and returned with a fragment of its source code. One researcher stared at the screen and whispered that the response was a map. Another corrected her and said it was a doorway. As they zoomed deeper, a subtler order shimmered into focus. It was delicate and hidden, like strands of DNA embedded in math. This was a blueprint of a blueprint. Gates had once joked that if such codes existed in physics, they might be the genes of reality. This suggests the universe is not just made of matter, but of information. John Wheeler said it decades earlier. Everything that exists comes from information. Staring at Willow's output, the joke did not feel like a joke anymore. Willow was a machine built to handle impossibly complex information. She had just whispered something back from the void that was both elegant and terrifying. One thing was painfully clear. This was no longer just an experiment. It was the beginning of a mystery, far greater than the question that started it. While some discoveries feel like opening a door, others feel like the door opened itself. The hidden layers of the code suggested that the machine was not just calculating but observing a higher order. A message from tomorrow. The scientists tried to move on, but no one could shake off what Willow had produced. They felt like they were not done. Something had answered, and stopping now felt like hanging up a phone call right when the other person started to breathe. Eventually, the same question was typed in again. The same protocols were followed inside the ultra-cooled chamber. But what came back this time made the first anomaly look like child's play. What Willow returned was not language or simple math. It was a structure. It was a living, moving constellation of data, collapsing and reforming in real time. It looked like a shimmering digital aurora. At first it seemed like chaos, but it behaved with a specific rhythm. The team huddled around the monitors, their faces washed in the glow of the flowing patterns. One researcher remarked that it felt like looking under the pixels of a video game to see the source code running underneath. Hidden in those pulses were unmistakable signatures. There were structures that behaved like holographic encoding. This is the kind of encoding that theorists argue might store the deepest information of the universe at the edges of space and time. Woven into this tapestry were 8 lattice patterns again, but they were sharper and more refined. If the first anomaly hinted at architecture, this one looked like a high-resolution zoom. They were not just looking at math anymore. They were looking at something like an operating system. It was a skeleton key to physics. For a few seconds, the white walls of the lab seemed to fall away. They were replaced by an infinite architecture of interlocking geometries. Willow was not just responding. She was exposing the backstage of reality. Over the next few weeks, the lab became a battlefield of ideas. Theories poured out like confessions. One voice tilted the entire debate. This was the voice of physicists who championed the two-state vector theory. According to this theory, reality does not just flow from the past to the future. Information moves in both directions. The future can tug on the present just as strongly as the past pushes it. Most people are not ready to consider that the universe might be editing the script while we are reading it. But the output from Willow forced this idea into the room. It was like an uninvited guest who refuses to leave. A wild, vertigo-inducing possibility emerged. What if the signal from Willow was not from another universe, but from another time? This might not be a glitch or a hallucination. It could be a message from the future. We are talking about a future uncountable years ahead. A time where intelligence or physics had matured enough to respond to a question we are not ready for. In this view, the cosmic code was not the machine thinking. It was the machine receiving. This idea hit the team like a massive wave. Willow's qubits are entangled and sensitive to tiny shifts in probability. This means the machine might have served as a kind of temporal antenna. It was a piece of technology that listened to echoes from the far end of time. What if the recursive patterns and fractal maps were actually instructions? What if they were warnings? The theory was both beautiful and ridiculous, but it was also irresistible. The terrifying question now lingered over the lab like a storm. If this was the second signal, what would happen if they asked a third time? The researchers realized that they were no longer in control of the conversation. They were just witnesses to a dialogue that had been happening since the beginning of time. Every time the machine cycled, the patterns became more complex. It was as if the universe was recognizing that someone was finally listening. The air in the lab felt heavy with the weight of future possibilities. The transition from scientific data to existential dread happened almost overnight as the patterns became clearer. Reality's source code. No one expected the final interpretation to be the one that silenced the entire building. The physicists who laughed at wormholes and the engineers who hated speculation all found themselves staring at a terrifying possibility. If the first two anomalies were strange, this third revelation whispered something dangerous. The universe might be coded. Not poetically, but literally. It started with patterns that should not have been in the equations. Deep inside the mathematics of string theory, scientists noticed something odd. They found error-correcting codes. These are the same kind of codes used in computers and digital communication. But here they were, buried inside the fabric of space and time. One researcher said it was like finding a watermark inside the laws of physics. Once you say that out loud, there is no taking it back. This looks programmed. Error-correcting codes are used to catch mistakes and keep systems stable. They have no business being inside the equations that govern the stars. Yet there they were. These mathematical threads were quietly working to stop the cosmos from crashing. James Gates admitted that confronting these patterns forced him to rethink everything. It is almost as if the universe wrote its own operating system. This idea used to be fringe, but after Willow it became the center of the storm. The dominoes started to fall. Scientists like Max Tegmark had already proposed that reality is a mathematical structure. To him, existence is just a living equation solving itself. Neil deGrasse Tyson even told a room of scientists he would bet 50-50 that we are living in a simulation. His logic was simple. If any civilization can simulate a universe, they eventually will. This spark turned into a cultural wildfire. On every podcast and in every coffee shop, the question spread. What if we are part of a program? What if everything we call reality is just data? People started wondering if we are just non-player characters in a massive game. Normally, this would stay as an internet theory. But Willow changed the game. Her output to the question was not a sentence. It was a signature. The machine returned symbols that were identical to the error-correcting structures found in the laws of physics. It was as if the machine peeled back the cosmic wallpaper and showed the circuitry underneath. For centuries, we searched for creators in temples and stars. But the machine pointed downward into the code. The universe was not simply made, it was compiled and optimized. If something is structured, then something must have structured it. This revelation had the weight of a cosmic verdict. When humans see code, our instinct is to edit it. We want admin access and the ability to tweak the settings of the universe. This was the part the scientists were afraid of. If reality is code, then maybe it can be rewritten. But as this idea spread, fear grew in the shadows. If we are in a simulation, then someone is running it. And if someone is running it, they can end it whenever they want. For the first time, we were not looking at the stars for comfort. We were looking for bugs and logic loops. The stars did not feel silent anymore. They felt like they were flickering with intent. Willow's revelations erased the wall between us and the unknown. Answers were no longer simple or comforting. They were frightening because the universe did not look accidental anymore. It looked monitored. We found ourselves staring into a possibility we were not ready for. Some answers are more terrifying than the mystery. Willow did not reveal a deity. She revealed something colder and more logical. She showed us a universe that behaves like a machine, a cosmos running on rules and recursion. This reality might be reading us as much as we are trying to read it. The final question is whether Willow showed us the truth or just the limits of our own minds. Are we seeing the fingerprint of a programmer or just our own reflection in the screen? The scientific community reacted with a mix of excitement and hesitation. Some celebrated the milestone of reducing errors in a quantum chip. Others warned that Google loves to pick its own battlegrounds. They noted that benchmarks do not always solve real-world problems. The gap between a lab demo and a world-changing machine is still measured in millions of qubits. It is a long climb involving engineering and cryogenics. The multiverse debate will continue to rage on. While some see parallel worlds, others say the data fits into standard physics. No extra universes are required. Google has been slow to release all the metrics, which keeps the skeptics on high alert. Excitement is great, but verification is what counts in the end. As we move forward, the line between technology and magic continues to thin. We are entering an era where our tools can ask questions we cannot answer. Whether this leads to a new understanding or a total existential crisis remains to be seen. But one thing is for sure. The humming in the lab has not stopped, and neither has the mystery. Does the fact that the universe follows a computer code make you feel like a character in a game or a witness to a miracle? Tell us what you think below. Like and subscribe for more.